Today we're going to take a look at, let's see if I can get this to come up, rational functions. So, if you want to label it as basic rational functions, there we go. We'll start to take a look at some of this here. So the first thing we are going to take a look at is, make sure you can see this, our parent function. So in the previous chapter, we've graphed f of x equals 1 over x. And if you remember what this graph looks like, it was, some of you called it the swoopy graph. And you could think of this like, let's make an xy table. When x is 1, 1 over 1 is 1. When x is 2, 1 over 2 is 1/2. When x is half, 1 divided by half is 2. And this had those asymptotes there. And then it was in the first and the third quadrant. So a couple things here. There are asymptotes on this. I think that's spelled wrong. So that line that it never crosses. So it never crosses the y-axis. So that's the equation x equals 0. And then it never crosses the x-axis. So that's the equation y equals 0. So if we were to find the domain on this, we would say, well, it's all reals, except x doesn't equal 0. And then if we were to find the range, we would say, well, that's all reals again, except y can't equal 0. So what we're going to do now is we're going to shift this around. So let's say we were to graph f of x equals 1 over x plus 3 minus 2. Well, just with translations, this moves it to the left 3 and down 2. So our graph I'm going to start by drawing in the new asymptotes. So instead of at x equals 0, it would be at x equals -3. And so I'm going to dash in the new asymptote here. And then instead of at y equals 0, it's y at -2 because the -2 moves it down. And then it's like we have just 4 new quadrants. So it would go right here, kind of like 1, 1, but it's moved to the left 3 and down 2. Oops, and it would go through right there. So we moved everything to the left 3 and down 2. So our domain would be all reals, except x doesn't equal -3. Our range would be all reals, except y doesn't equal -2. And now a couple things here. We could also find our y-intercept. If I wanted to know exactly where this is, the y-intercept's easy to find because all we do is we plug in 0. So for our y-intercept, we'd say y equals 1 over 0 plus 3 minus 2. So 1/3 minus 2, so that'd be -1 2/3. So that's where that coordinate right here, we could label that as 0, -1 2/3. So let's take a look at one more like this. So let's say we had f of x equals 2 over x minus 1 plus 3. Well, -1, so this moves it to the right 1 and up 3. So our new asymptotes would be at x equals 1 and y equals 3. So if we were to graph this, y equals 1 and 1, 2, 3. And we don't have to worry about the exact points. We're just going to make a sketch of this one because the 2, that's at vertical stretch. But all we need to know is that there would be a swoop in this quadrant and in that quadrant. And so we could say our domain, again, x is all reals except x doesn't equal 1. And our range is all reals except y doesn't equal 3. And then we could find our y-intercept here. So our y-intercept, 2 over 0 minus 1 plus 3. So that'd be negative 2 plus 3, or negative 1. So we could draw this more accurately. And we could erase part of this, because we know that, oops, it crosses the y line at negative 1. So now what we're going to do is we're going to take a look at some that are a little bit more complicated. So you're going to paste this into your graph and into your notebook, and the first thing it says is to factor this. So for example, this top one, we can factor out a 2. So it would be 2x minus 2, x minus 4. This one can't be factored. What about this top one? Well, we could factor out a 4. So then it would be x squared minus 1. The bottom is difference of squares, x minus 2x plus 2. And I guess this is difference of squares too, so this could be x minus 1, x plus 1. Can't factor, let's see, this bottom one, we can factor out a 3, so 4x minus 1. Factor out a 6, x minus 3. And let's see this one, x minus 4, and then difference of squares, x minus 3, x plus 3. So the next thing you're going to do is you're going to go to Desmos and you are going to graph this. So, and you can just graph the regular one. So let's see here, let's go to Desmos. And I'm going to, so I already forgot what it was. Shoot. 2x minus 2. So in parentheses, the top part, 2x minus 2. Try this again. So 2x minus 2 divided by, and I can't even remember what it was divided by, x minus 4. So here's this graph here. And so now it's asking us to come up with some asymptotes. Well, let's see. Where does it look like this vertical one is at 4, and then a horizontal one at 1, 2. And I could check that. Let me see. X equals 4. Yep. And let's try y equals 2. Oops. Equals 2. Yeah, so it looks like it never crosses those. So I'm going to go back here. So vertical was at x equals 4, y equals 2. So the domain, all reals, x can't be 4. All reals, x can't be 2. Then it says the y-intercept. So we can just use Desmos here. Let's see the y-intercept if we click on it. So the y-intercept is 0.5 and the x is 1. So the y-intercept 0.5, the x-intercept 1, 0. So what I want you to do is take a few minutes and go through this. And then once you're done, unpause the video and then we'll talk about it. So hopefully you figured out a couple things from here. Where to find your vertical asymptotes. Your vertical asymptotes, it makes a 0 in the denominator. Now our horizontal, we had a lot of different numbers up here. So if we go back to, let's see, this one was y equals 1, y equals 4, y equals negative 3, y equals 2, and y equals 0. And to find a horizontal asymptote, some of you guys might recognize there's some coefficients there. We have to look at the degree. So if we look at the degrees here, do you see on all these top ones, our degree on the top and the bottom is the same? When it's the same degree, then we just divide those leading coefficients. So when our we look at degrees. And when the numerator equals the denominator, all it is the leading coefficient over the leading coefficient. When the numerator is less than the denominator by 1, then it's automatically at y equals 0. So if we take a look at this bottom one here, that was obvious. That was a quick y equals 0, and we can tell by the equation here, because if we look at those coefficients, or excuse me, the degrees, the top one is 1 and the bottom one is 2. The numerator is less than the denominator. And so the last things we looked at were the y-intercepts. Well, that's easy. Plug in 0 for x. And the x-intercept. Well, that's pretty easy. Plug in 0 for y. So let's take a look at one and see if we can find this stuff without looking at the graph. So let's say we had f of x equals 2x plus 5 over x minus 3. Well, our vertical asymptote, we look in the denominator. So it's at x equals 3. Our horizontal asymptote, so if we look at our powers, they're the same. So it would be y equals 2 over 1, which would just be 2. Our y-intercept, we plug in 0. So 2 times 0 plus 5, 0 minus 3. So we have negative 5/3. And our x-intercept, 0 for y, so 0 equals 2x plus 5 over x minus 3. And now we can solve this because we've been solving these rational equations. So let's see, 0 times x minus 3 is 0, equals 2x plus 5. And if we solve that, we'd have subtract 5 and divide by 2. So if we were to graph this here, let's see, a vertical at x equals 3. Horizontal at x equals 2. Y equals 2, excuse me. A y-intercept of negative 5/3, so a little bit more than 1. And an x-intercept of negative 5 over 2. So we know our swoops are in this quadrant. And then it would go right up. That one didn't dash far enough for us. Right up here. So let's take a look at one more. Let's say we had 2x over x squared minus 4. Well, this factors into 2x, x minus 2, x plus 2. So one way I notice is our verticals are at x equals 2 and x equals negative 2. Horizontal is going to be at y equals 0. Our y-intercept, if we plug in 0, we would have 2 times 0, 0 squared minus 4, 0 over negative 4, which is 0. Our x-intercept, when does 0 equal 2x over x squared minus 4? So if we fraction bust this, x squared minus 4, 0 equals 2x, so x equals 0. So this one, we got a lot going on here. We got a couple verticals. So x equals 2, x equals negative 2. And then there's one right at 0. And we know it crosses at 0, 0. So what does this look like? Well, this might be something where we might use a table. So what about when x is 1? We could make an xy table. When x is 1, 2 times 1 is 2. So on top we have a 2. 1 squared minus 4 is negative 3. So when x is 1, we got negative 2/3. What about when x is negative 1? So 2 times negative 1 is negative 1. Or negative 2, excuse me.